Okay, first, if you were just looking at this function, x squared, would you think it's 1 to 1? What's the shape of the graph? It's a parabola, right? It's a parabola with the vertex at the origin. Does that pass a horizontal line test? If you do a horizontal line, if it intersects in more than one place, it fails the horizontal line test. So that's not 1 to 1. Remember the other one you could say, is it always increasing or always decreasing? Well, in this case, it's decreasing and then increasing. So it fails that test too, right? So it would look like it's not 1 to 1, but they tell you we only want the x greater than or equal to 0, which means to the right of the y-axis. So we don't have this piece right there. That's not part of the graph. Okay, just looking at 1/2 of the parabola, it doesn't look like it's 1 to 1. Yeah, now it's always increasing. Now it passes the horizontal line test. Okay, so then once we've got that into account, the domain is this. What is the range? Yeah, y greater than or equal to 0. Okay, now let's do our steps to find the inverse. Y equals x squared. X equals y squared. Take the square root of both sides. Y equals plus or minus the square root of x. Okay. Now, if I was looking at this is a square root function, which I'll put it in red, would have two parts. The plus part means this. The minus part would go down from there, right? But remember, the domain of this is the range of that. The range of this is the domain of the inverse. In this case, it's all the same thing anyways. But what that means is this piece, which is below the middle, is not part of the inverse. It can't be. Right? It's only this piece here. So I could take that part off. Right. Now the last part is, what do you notice about the graphs of a function and its inverse? They are symmetric with respect to what line? Y equals x. Right. If you drew a line right through it should look like they're just mirror images on either side.